Question. This is the cat replica question. Cat replica question. Generally, it takes a half page to solve, but once you understand, you can solve this question in less than 1 minute in 2 steps. Question. How many 3-digit numbers? How many 3-digit numbers on cubing ends with, first question, how many 3-digit numbers on cubing ends with 28? How many 3-digit numbers on cubing? The same question we did it for squares yesterday. How many 4-digit perfect squares will have tens place odd number, tens place even number, unit digit so and so particular value? How many 3-digit numbers on cubing ends with 28? First, let me read the question. He is saying that there is a 3-digit number. Let me call the 3-digit number as ABC. On cubing, okay? On cubing. It is ending with which number? It is ending with 28. It is ending with 28. Now, because it is ending with 8, just now we discussed a perfect square never ends with 2, 3, 7 or 8. On cubing, I will get the tens minus unit digit. 10 minus 2, 8, 10 minus 3, 7, 10 minus 7, 3, 10 minus 8, 2. So for it to become 8 in the right hand side, this should become 2. This should become 2. 2 cube is 8. I hope the concept is clear. So first lowest number on cube, 2 cube is 8. 8 is 08. 8 is 08. But I require 28. Next number is 12 cube. 12 cube. If I do a plus b whole cube, I will get 1728. 12 cube, most of you know. 12 cube is 1728. 1728. So the lowest number on cube, I will get 28 at the end is 12 cube is 1728. What is the logic that we discussed? X cube and 50 plus x whole cube. X cube 50 plus x whole cube. Last 2 digits will be same. Last 2 digits will be same. When it will be same? When x is an even number. Is 12 an even number? Yes. So if it is 12 cube, what will be the next number? 12 plus 50, 62 cube. What will be the next number if x becomes 62? 112. What will be the next number? 112 plus 50, 162. And so on up to 912, 962. I hope it is clear, right? First, we have to get the lowest number on cubing. Last 2 digits should be same. X cube. These ending with 8. Which number on cube ends with 8? 2 cube it is 8. But I want 28. 2 cube not possible. 12 cube is 1728. So, to get 28, the lowest 2 digits we got it is 12. The lowest 2 digits which we got is 12. We got 12. But we require a 3-digit number. So hundreds place can range from 1 to 9. Yes or no? It can be 112, 212, 312, 412, 512, 612 and so on up to 912. If it is 12, 50 plus 12, 62 cube. Next number is 62. I want a 3-digit number. So hundreds place can take any value from 1 to 9. 9 plus 9. Answer is, how many 3-digit number on cubing I will end with? 28. Answer for this question is 18 numbers are there. What are that 18 numbers? 112, 162, 212, 262, 312, 362, 412, 462, and so on up to 912, 962. The student who know this logic, it is just less than 1 minute. Only thing is, you have to find out the lowest number on cube, which one will end with 28. Once we got the value of x, then it is nothing but Keep on addition of 50. X is 12. 50 plus 12 is 62. 62 plus 50 is 112. 112 plus 50 is 162. 162 plus 50 is 212, and so on up to. So I got the lowest two-digit number 12, 62. Because it is a three-digit number, hundreds place can move from 1 to 9. Hundreds place can move from 1 to 9. 1 to 9, 1 to 9. 9 plus 9. 9 plus 9, it is nothing but 18. 9 plus 9, it is nothing but 18. I hope the idea is clear. We are discussing the logic where x is an even number. Again, I will take a speed calculation class. Then we will discuss whether odd number it is possible. Now, Karthik is asking, if last digit ends with 21, so 1 cube it is 1. So try it out with 11 cube, it is nothing but. Now see here. I will just park your idea for 2 minutes, then I'll take your question. Karthik, good doubt it is. First we will do an even number, then I'll come to the odd number. 28. I hope the idea it is clear. Please put a star mark. Neither these questions nor these logics, you will find it in any of the regular YouTube channels. Most of the teachers teach at a particular level because they are into teaching by solving problems. I am teaching because of my interest towards research. Now, next one. Karthik, just 2 minutes. One more question, then we will do. How many three-digit numbers? How many three-digit numbers on cubing ends with one more problem we will solve so that the concept will be very easy to you. How many three-digit numbers on cubing it ends with 44? It is ending with 44. Step number one. It is a three-digit number. Let me take three-digit numbers less than 500. Why to take the same question? How many three-digit numbers? How many three-digit numbers less than 500 on cubing ends with 44? It is a three-digit number. ABC whole cube. It is ending with 44. It is ending with 44. Because this is 4, we know that 4 cube only will give you 4 at the end. So the unit digit in the left hand side, it is nothing but 4. 4 cube, it is 64. 4 cube, it is nothing but 64. Suppose if I take the next number, 14 cube, that is exactly the reason why I discussed a cube 3a square b, 3ab square and b cube. These 1, these 3 4s are 12, 16 3s are 48, 4 cube is 64, 4, 6 carried, 48 plus 6 54, 5 carried, 17, 2 7 4 4. I got 44 at the end. So 1 is 14 cube I will get, 14 cube plus 50, 64 cube I will get. I want a three-digit number less than 500. 114 cube possible, 214 cube possible, 314 cube possible, 414 cube possible. Here 164 cube possible, 264 possible, 364 possible, 464 possible. 4 plus 4. Totally how many numbers are there less than 500? On cubing it ends with 44. Answer is 8. ABC whole cube, it is nothing but 44. Which number on cube I will get 4 at the end? 4 cube is 64. 4 cube is 64. Then I did 14 cube. Just to solve the problems easily, that is the reason I did a plus b whole cube. A plus b whole cube is a cube 3a square b, 3ab square and b cube. So 14 cube I got 2744. I need 44 at the end. 44 at the end. Now see here. For 14, we got x cube and 50 plus x whole cube. Last two digits will be same. 14 plus 50, 64. 64 plus 50, 114 plus 50 plus 50 plus 50 plus 50 plus 50 plus 50 plus 50. I will stop at 464 cube because I want three-digit numbers less than 500. I hope the idea it is clear. On cubing ends with 44. Now, Karthik is asking 21. Karthik, I'm sure you can try it out, right? So to get 21, 1 cube it is 1. You can try it out 11 cube, which is 1331. Try it out with 21 cube. In case if you are getting 21 at the end, take 21. Otherwise, try it out with 31, 41 and so on. I hope the idea behind the question is crystal clear to you. How many three-digit numbers less than 500? On cubing, it ends with 44. Idea clear? Full, sir. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. But reverse may or may not be true. May or may not be true. Please make a note of it, sir. But reverse may or may not be true. Very, very important key points. Right? Every perfect square has a digital sum 1, 4, 7 or 9. But reverse may or may not be true. We will see the proof. Then we will understand it clearly. Anything, whatever I am explaining the concept, if need be, I will create a proof for it. Suppose, see here. First, we will underline some important keywords. Keyword, first one, it is digital sum. What are the important keywords? Another, it is perfect square. And the digital sum value will be 1, 4, 7 or 9. These are the three important keywords. Suppose 1, 2, 3, 4, it is there. Digital sum or digit sum in both the ways, or digital root, all are synonyms. Digital sum is nothing but sum of the digits till a single digit is obtained. Digital sum is defined as sum of the digits till a single digit is obtained. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 is a two-digit number. So 1 plus 0, it is 1. 1 plus 0, it is 1. 2.37. 2.37. Point is not a digit. So just add the digits. 2 plus 3, 5. 5 plus 7, 12. 12, it is nothing but 3. 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 Every perfect square has a digital sum 1, 4, 7 or 9. But reverse may or may not be true. Now, because the definition of digital sum is till a single digit is possible, all the digital sum values are digital sum. All the digital sum values will range from 1 to 9. Why? Because we are doing the sum of the digits till a single digit is obtained. 0, it is not possible. If you add the digits, digit 0, that is not possible. So what are all the values digital sum will take? It can take either 1, either 2, either 3, right? Or till 9, because these are all the single digits that are possible. Digital sum definition is sum of the digits till a single digit is obtained. Next slide is extremely important, sir. Digital sum. Now see here. Suppose, what are all the various possible digital sums? Various possible digital sums are. Digital sum is nothing but the sum of the digits. Sum of the digits. Digital sum is nothing but the sum of the digits till a single digit is obtained. These are all the possible digital sums. These are all the possible digital sums. Suppose if I say 19. 19, what is the digital sum? 1 plus 9, 10. 1 plus 0, 9. Suppose if I take 299. What is the digital sum? 2 plus 9, 11, 11 plus 9, 20. 20, it is 199 we will take. 199, the digital sum is 1. Suppose, for example, 8, 11, digital sum is 1. This is the set of all the numbers whose digital sum is 1. Set of all the numbers. Set of all the numbers where the digital sum is 2. Set of all the numbers whose digital sum is 3, 4, 5, 6, 7, 8, 9. Now listen carefully, sir. Now listen carefully. When I am explaining a concept, I will not see the comments. Just have some patience. Suppose if I square it, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 16 digital sum is 7, 5 square 25, 2 plus 5 it is 7, 6 square 36, 3 plus 6 it is 9, 7 square 49 which is 4, 8 square 64, 6 plus 4 10 which is 1, 9 square 81, what is 8 plus 1 9. What are all the right hand side, what are all the numbers that we got? We got 1, 4, 7 or 9. If a number is a perfect square, if a number is a perfect square, left hand side all the possible cases we have taken, square for all the possible digital sums we have taken. Right hand side, these are all the possible digital sums. If I square it, I will get a perfect square. Right hand side, I got 1, 4, 7 or 9. If a number is a perfect square, extremely important logic, sir. If a number is a perfect square, the digital sum should always be 1, 4, 7 or 9. If this is happening, this should happen. Reverse may or may not be true. 22 it is there. What is the digital sum of 22? 2 plus 2 it is 4. Is it a perfect square? It is not a perfect square. So reverse may or may not be true. If the number is a perfect square, it should have digital sum 1, 4, 7 or 9. If a number digital sum is other than 1, 4, 7 or 9, it is not a perfect square. If it is 1, 4, 7 or 9, it may or may not be perfect square. If I given to check whether a number is a perfect square or not, use the digital sum. If the digital sum is any digit other than 1, 4, 7 or 9, then it is not a perfect square. Then it is not a perfect square. Then it is not a perfect square. Now, remember everything, sir. Digital sum. Digital sum. It is an elimination method. It is an elimination method. It is an elimination method. You should know when to use digital sum, when not to use digital sum. It will tell which answers are wrong. It will tell which answer options are wrong. It will never give you the exact right answer, but it will tell you which answer options are wrong. Which answer options are wrong, right? When to use. Most of the teachers don't tell this. That is the reason most of the students get confused when not to use. When not to use. When not to use. When to use. It can be used in all the decimal values wherever there is a terminating decimals. Terminating decimals. It will help us in eliminating incorrect answer options. When not to use. You should never use these logic for a recurring decimals. I will explain in detail by taking a problem. You should never use these logic in the problems where the values are approximated. Very, very important key point, sir. Very, very important key point. Many students will think that this method has merits, and this method also got demerits. You should have a very good understanding of usage of digital sum. Please make a note of it. Right? Digital sum. Digital sum is an elimination method. It will only help if there are answer options. It will only tell you which answer options are wrong. By any chance, if 3 are wrong, 4th will be the option. Probably if there is none of these, or if there are 2 options with the same digital sum, you will stuck at this method. Digital sum. When to use these digital sum? Digital sum is used for all the values when it is a terminating decimal. When it is a terminating decimal. Now you please make a note of it. What is a terminating decimal? Denominator can take either powers of 2 or 5 or 2 and 5. DR is denominator. DR is denominator. Only when the if you can express denominator as a power of 2 or a power of 5 or a power of 2 and 5, then it will result in terminating decimal. Otherwise, it is a recurring decimal. When not to use this concept, please don't use this concept. When the given decimal, it is a recurring decimal, or if the question is saying about approximation. Question is saying about approximation. Now let me see the comments. Now, Karthik, good that I have explained without seeing your comments. I'm sure I understood from experience that some students will be struck. Now see here. Questions. Please write down, sir. Is 123321. Is 123321. Without doing the fundamentals, let us not solve the problems. Is 123321. Is 123321 a perfect square? Is 123321 a perfect square? How to check whether a number is a perfect square or not? Now see here. Steps to check whether a number is a perfect square or not. Steps to check whether a number is a perfect square or not. Suppose take a number. Unit digit cannot be 2, 3, 7 or 8. 2, 3, 7 or 8. If the unit digit is 2, 3, 7 or 8. If the unit digit is 2, 3, 7 or 8, then it is not a perfect square. If the unit digit is 2, 3, 7 or 8, it is not a perfect square. If the unit digit is not 2, 3, 7 or 8, go to the next step. A perfect square should be of the form 4k or 4k plus 1. 4k or 4k plus 1. 4k or 4k plus 1. This is something which we discussed. 4k or 4k plus 1. Next one. Many students do not know this flow chart. No, it is a perfect square. If the number is not of the form 4k or 4k plus 1, 4k or a 4k plus 1, if it is not of the form 4k or 4k plus 1, then it is not a perfect square. If it is of the form 4k or 4k plus 1, then use the logic of digital sum 1, 4, 7 or 9. Then use the logic of digital sum 1, 4, 7 or 9. This flow chart should be extremely clear to you. If a number is given to you, how to check whether a number is a perfect square or not? If the unit digit is 2, 3, 7 or 8, definitely it is not a perfect square. If the unit digit is not 2, 3, 7 or 8, check whether the number is of the form 4k or 4k plus 1. If it is not of the form 4k or 4k plus 1, then it is not a perfect square. If it is of the form 4k or 4k plus 1, then use this logic of digital sum of a perfect square. Now, step by step, we will see. There is a number given. Unit digit is not 2, 3, 7 or 8. This step is satisfied. Second step, check whether the number is of the form 4k or 4k plus 1. 21. 21 is 4 into 5 plus 1. Answer is yes. Now apply digital sum. What is the digital sum of this question? Digital sum of this question is 3, 9, 11, 12. Digital sum is 3. Then it is not a perfect square. I hope the idea it is clear. It is a 3-step process to check whether a number is a perfect square or not. First step, perfect square never ends with 2, 3, 7 or 8. Second step, every perfect square should be of the form 4k or 4k plus 1. If it is of the form 4k or 4k plus 1, then its digital sum should always be 1, 4, 7 or 9. 1, 4, 7 or 9. I hope the idea it is clear. Answer for this question is no. Answer for this question is no. I hope the idea it is clear. Next one. Second question. Is 3 questions will solve. Is 122 333 44444 a perfect square? Is 122 333 44444 a perfect square? These is nothing but 1 plus 2 plus 2, 2 square, 3 plus 3, 3 square. Next is 4 square. These is nothing but 16 plus 9 plus 4 plus 1. These is 30. Again the digital sum is 3. Is it a perfect square? It is not a perfect square. It is not a perfect square. I hope the idea it is clear. Generally in our textbooks, only these 3 will be given. Only these 3 will be given. 1 plus 2 plus 3. Sum of the n natural numbers is n into n plus 1 by 2. Sum of the squares of the natural numbers is, and so on. Only these 3 will be there in your textbook. N into n plus 1 into 2n plus 1 by 6. Last one. Sum of the cubes. But in your examination, he might ask you another model also. N cube is n into n plus 1 by 2 whole square. These 3 will be there. Please make a note of remaining 2. These 2 are very, very important. Sum of the cubes of the odd numbers. 1 cube plus 3 cube plus 5 cube. It is nothing but n square into 2n square minus 1. Very, very important. Please make a note of it. 1 square. Sum of the squares of the odd numbers. 1 square plus 3 square plus 5 square. It is given by n into 4n square minus 1 by 3. Please make a note of these 2 points which you will not find it in the regular questions. These 3, most of you know it. Sum of the first n natural numbers, sum of the squares of the first n natural numbers, sum of the cubes. These 2 are very important. Sum of the squares of the odd numbers. n into 4n square minus 1 by 3. n into 4n square minus 1 by 3. Sum of the cubes of the odd numbers. 1 cube plus 3 cube plus 5 cube. It is n square into 2n square minus 1. n square into 2n square minus 1. Now, why we discussed this? Because I got squares of the first 4 natural numbers. So I thought, what if the question is a sum of the cubes? Anyway, this formula also we will not use. In my averages class, I will use it with the logic of progressions and a power n plus or minus b power n. These 2 problems, first 2 are basic problems. How the questions will be asked in a CAT, we will see the third question. These 2, please make a note of it. This is something which you know, this is something which you need to know. Now see here. Next one, please write down, sir. This is a very, very good CAT question. How many 5-digit numbers? How many 5-digit numbers? How many 5-digit numbers? How many 5-digit numbers that can be formed? How many 5-digit numbers that can be formed using the digits? Using the digits 1, 2, 3, 4, 5. Repetition not allowed. A CAT replica question, sir. How many 5-digit numbers? Repetition not allowed. Are perfect squares. Are perfect squares. Very, very good question based upon the logic that we are discussing. A CAT replica question. Please write down this question. Please write down this question. Himanshu is asking, are you from South India? Yes. Right? How many 5-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. Repetition not allowed. Are perfect squares. Are perfect squares. Now listen carefully. Beautiful question, sir. Put a star mark on this question. This question is a very beautiful question. How many 5-digit numbers that can be formed using the digits 1, 2, 3, 4, 5? First thing, whenever you are solving a CAT question or any of the aptitude question, start reading the question, underline the keywords. I want a 5-digit number. 5-digit number. Perfect. That can be formed using the digits 1, 2, 3, 4, 5. These are the 5 digits. Repetition is not allowed. Repetition of the digits is not allowed. If I am using 1 in any of the 5 places, 1 cannot be used anywhere. If I am using 2 anywhere in a particular place, that cannot be used anywhere. Are perfect squares. How many are perfect squares? Now see here. Total this place can be filled by any one out of the 5 digits. 1, 2, 3, 4 or 5. Repetition not allowed. So remaining 4 digits, 1 digit will come. Remaining 3 digits, 1 digit will come. Remaining 2 digits, 1 digit will come. Remaining 1 digit, it will be there. This place can be filled in 5 ways. This place can be filled in 4 ways, 3 ways, 2 ways, 1 way. Suppose here 1 can come, 2 can come, 3 can come, 4 can come, 5 can come. If I fix 1 digit, remaining 4 digits, any one will come. Remaining 3 digits, any one will come. Remaining 2 digits, any one will come. Remaining 1 digit, any one will come. Total one event after the other event. 5 into 4 into 3 into 2 into 1. Total 120 numbers are there. 120 numbers. Which are all the numbers? Are perfect squares, he is asking. Which all numbers are perfect squares, he is asking. Very good question. Students who think logically will get this answer very fast. Can I say one number will be like this? 1, 2, 3, 4, 5. Is there any digit that is repeated? No. 1, 2, 3, 4, 5. All the 5 digits are used. A number can also be like this. 5, 4, 1, 3, 2. A number can also be like this. 4, 2, 5, 1, 3. It can be any such number. Please find the digital sum of these number. Digital sum is 5 plus 4, 9, 12, 14, 15. 15, it is nothing but 6. If I interchange the digits, will the digital sum change? 5 plus 4, 9, 10, 13, 15. 15, it is 6. 4 plus 2, 6, 11, 12, 15, 6. All the numbers, digital sums are 6. 1 plus 2 plus 3 is also equivalent to 2 plus 1 plus 3. It is also equivalent to 3 plus 1 plus 2. If I interchange the digits, the sum of the digits will not change. All the 120 numbers, what will be the digital sum value? Digital sum value is nothing but 6. For a number to become a perfect square, what should be the digital sum? 1, 4, 0, 7 or 9. Answer is no 5-digit numbers are perfect squares from the digits 1, 2, 3. No 5-digit numbers satisfy the property. Very, very good question. He will not ask you by giving a number whether it is a perfect square or not. If you observe, first 2 questions are very primitive questions. Third question, it is a CAT replica question. This is how I am going to take a CAT class. How many 5-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. Stepwise, again I am saying, it is a 5-digit number. Units place, tens place, hundreds place, thousands place, 10,000s place. Step number 1. Repetition of digits are not allowed. So if I keep 1 here, I cannot keep 1 anywhere else. So the units place can be taken by any one out of the 5 digits. Remaining 4 digits, remaining 3 digits, remaining 2 digits, remaining 1 digit. It is one event is happening after another event. Total 120 numbers are formed. Suppose if I take example one number, 1, 2, 3, 4, 5. Repetition of digits is not allowed. So if I change the order, this can also be one number, this can also be one number. Like this, total 120 numbers are there. What is the sum of the digits? 9, 12, 14, 15, 6, 6, 6, 6. All 120 numbers digital sum is 6. All 120 number digital sum is 6. For a number to become a perfect square, digital sum should be 1, 4, 7 or 9. A beautiful CAT replica question which is Nothing but a conceptual question, which is nothing but a conceptual question. Any student who listen to more and more concept-driven YouTube live classes. Anyway, students right now are very smart. By listening to a class, they will understand whether a teacher is doing a lot of entertainment or he is giving you the concepts. Entertainment will make you happy, but it does not serve the purpose.